In this video lesson, we're going to look at using the solubility table to predict whether a compound is soluble or insoluble. To get the most out of this video lesson, you're going to need a copy of our solubility table that we're going to use in class, which looks like this. If you look at this solubility table, you can see a couple things. Along the top right here are anions, and down along the left-hand side are cations, positively charged metals. The majority of compounds we're going to use in double displacement reactions are made up of a combination of these cations and these anions. So basically, to determine the solubility, you find where they meet, and if there is an S, we can see down here, it tells us that it is soluble, and if there is an I, it means it is insoluble. So one thing I want to note here is that the S means soluble, not solid. S means the subscripts after the compound formula in an equation is going to be AQ. And then if we have the insoluble right here, it means the subscript after the formula is an S for solid. So let's use our solubility table to predict the solubility of a couple examples. The first one we're going to look at is KOH right here. So in order to use the solubility table, we find our cation, which is potassium, which we can see is right here, and we find our anion, which is hydroxide, which we can see is right here. And then we find where they meet. So potassium all the way across here and hydroxide right here. And what we can see is that they are meeting where there is an S. So that S is telling us that it is soluble. So we write KOH is soluble. Look at another example, iron Fe2S. We find our cation is iron, Fe, and it's Fe3 right here, S for sulfide right here, and where they meet, just bring your pencil across and down, or use your two fingers, and we can see that they are meeting right here at an I, and so that tells us that Fe2S is insoluble. And then our last example that we'll look at is zinc sulfate. Find our zinc Zn2 right here, sulfate SO4 2 negative here. Find where they meet all the way across and all the way down. And they're meeting at an S. So therefore we can say that zinc sulfide, or sulfate, sorry, is soluble. So go ahead and give this a try. Predict the solubility of calcium hydroxide and lead iodide using the solubility table. So just make sure you hit pause, then give these a shot. So if you follow where calcium and hydroxide meet, they meet right here where it says SS. So that is a slightly soluble. So we'll learn in class a little bit later on whether or not to make the slightly soluble an insoluble or a solid or an aqueous solution in a chemical equation. But for now, just leave it alone. And then if you look where lead and iodine meet, they meet right here at an I, so it is insoluble. So we write right here. Okay, so that's the end of our using the solubility table tutorial. You'll be using this as to predict products of double displacement reactions in our next lesson. But for now, do the practice that's outlined by your teacher on your handout. Okay, and that's it for today.